So if you, so BA squared BA, so BA squared BA squared and BA, you end up at A cubed. So where does that come from? So that by that, so BA squared by BA squared by BA is A cubed. So where did this come from? So again, you do the algebra, right? You use the relations, right? Let's prove that. BA squared times BA, all right? It's sometimes, you have to scratch your head a bit sometimes. It's not always obvious. You have to think a bit and use some tricks, algebraic tricks. Okay, so BA squared BA is the same thing as split this into 2A. So you get BA, A, BA. Well, there's your ABA again, which you can just label as B, right? So now you've just got BAB. There it is, BAB. So here we are again, BAB. But we know that AB is BA cubed, right? So for here, substitute BA cubed. So then you get B squared A cubed. But B squared is just a double flip, right? Which is the unit. If you flip twice the same operation, you get the unit. So B squared's E, okay? So this B squared becomes E, and you're just left with A cubed, which is that. All right. Let's try some other. You can, using these relations, you can fill in the whole table in the form of having B's on the left side, right? And so so that they match with these. So you get you get closure, right? It's got to be a group. You have to get closure. All right. Well, let's try this one. These are just examples. You need to do some homework and fill in the whole table. So do that as homework. Create this table. Now BA squared. So BA squared is just A. BA squared is A. So show that this is A. Right? Well, that's BA squared. BAB is just B, right? BAB. So you get BA. Oh, sorry, it's ABA. Okay, so split this A into two A's. So you'll get B outside, you get A, B, A in the middle, and A, that's B, right? So B squared, that's E, and you're just left with A. Okay? Now, I've only given you a taste, a sample. Just go through systematically and generate the whole table. And generate this as homework. Right? Okay, so we have this group D4 with these elements rewritten in terms of generated elements, in terms of two generators, A and B. A is, well, just R actually. It's just a 90-degree rotation. And B is any one of these four flippers, flip operations. Rotation, well. Okay, next topic a bit. What are the subgroups? What are the subgroups of this group? All subgroups. Okay, well, I just said, A is the rotation about, oh, sorry, not here. Well, firstly, you have the two trivial subgroups, right? The trivial group, which is the smallest possible group, which is just when the set is just the unit operation, the unit. So that's the trivial group, and the group itself, right? So they're both, strictly speaking, they're still both subgroups. So you have those two. You're asked to find all subgroups. Now they're all subgroups. They all have to contain their unit, right? So you'll have this E in all of them, because a subgroup is still a group, and a group must have the unit, so they all have E in them. Now, why is this a subgroup? What is A squared? It's a rotation by 180 degrees. Right? So A squared by itself is A to the fourth. That takes you back to where you started. So yeah, I don't think it's very difficult to appreciate that will be a subgroup. I mean, it's obviously a subset, but show that it's a subgroup. So again, homework. Here you've got well, so is there, but here's a cyclic group of where your generator is just A, right? So a 90 degree turn, then a 180 degree turn, then a 270 degree turn, and so on. That's a subgroup. Now, B is any one of your flip operations. So if you flip twice, you get back to E. So that's a subgroup. Now BA, that's less obvious. What does BA do? BA, well, it'll be one of these. Oh, I see. So BA is just one of these flip operations, right? So E, and it's sort of like that. So if that one's, I don't know, say H, this will be one of the others, and similarly with these, right? So you've got four here of similar nature, namely E and one of the flip operations, right? So also subgroup. Now, what's this one? They're getting less and less obvious now. Yeah, I haven't given a lot of thought about that. Okay, I'll throw that to you as homework. Why are these two subgroups? Right? All right. Now, towards the end of the previous session, I said I would not only explain how to express D4 in terms of two generators, A and B, and well, perhaps I should backtrack slightly. I said I'd talk a little bit about relations and the presentation of a group. I can give you the presentation of D4, that means a description of the group, in terms of two sets of things. One set is the generators, so in this case just be the set of A and B, right? And the other set is the set of relations. So I would give you A to the fourth is B squared is Z, and ABA is B. Now, with the two generators and these relations, you can generate the whole table. And remember, if you have a group table, you know everything there is to know about that group, that finite group. Right? The table has everything. So, so when you hear the term presentation of a group, you expect to see two things: the set of the generators and the set of the relations. Yeah, this kind of thing. And different group, maybe different generators usually, and different relations. Okay. So presentation, in short, is the generators and the relations. Okay. All right. Okay. Now let's generalize. Let's go to I rubbed it off, but an n-gon. So a regular polygon of n sides, and what are its symmetry operations, and what would its group table be, right? So let's generalize to n. All right. So well, let me ask you, what would the presentation of dn be? Right? So so I'm asking you, what are those two sets? The set of the generators. You know, what are the generators of this group, and what are the relations? All right. Well, I'll just throw it at you a little bit. I mean, it just had to be discovered, of course. Let A here be the rotation of 360 degrees, or 2 pi radians, divided by n. Now n is now the number of sides. So for example, if we're talking about like a 5-gon, in other words a pentagon, right? A regular pentagon, or a hexagon, a 6-gon, then this would be, say for a pentagon, this would be 5. So your angle that you're rotating it through, this, would be 1/5 of a full rotation. In other words, 2 pi over 5 radians, right? Or 360 degrees divided by 5, whatever that is. Okay, 60, what is it? Whatever. Right? Now what about B? Now this is less obvious, and if you really want to prove it, good luck. B is any one of the flip operations. Yeah, you see why I wish you good luck. Now, how many? Well, that raises an interesting question. You're trying to generalize. Now, imagine you're the research mathematician, playing with these ideas for the first time. You can ask yourself, well, how many flip operations are there when you have a regular n-gon? Well, you might think it depends on whether your polygon has an even or an odd number of sides. Maybe you have to make a distinction there a bit. You might have to think a little. But it works out that if you have an n-gon, an n-sided polygon, you will have n flip operations for all n. Okay? So let me make that sound plausible, at least say for the pentagon. Now we're talking about the flip operations, right? The dihedral, two-faced type operations. Well, one symmetry operation would be to flip that way, right? About this axis 1. Another for the pentagon. Another one would be to flip about this axis 2, like and 3 and 4 and 5. Right? So when you have odd number of sides, your axis of flipping, your axis will go from one vertex to the midpoint of the opposite side. Make sense? And when you have an even number, and there are 5 operations, right? It's a pentagon, and there are 5 flip operations, and so equals to n. Now, how about when you have an even number of sides? What are the flip operations then? Well, when you have an even, you can one axis of rotation would be from midpoint to opposite midpoint. Another possibility is to go from vertex to opposite vertex. Right? So midpoint to midpoint, vertex to vertex, midpoint to midpoint, vertex to vertex, and so there you have 6 axes, and hence 6 flips for 6 sides. And you can generalize that argument to any n. Right? Leave that as an exercise. Alright? So now, if you're rotating about this, you will need to apply this n